twins, I'm just thinking, how much of correlation did you get between the blood and the brains if you did look at that? I'm not sure.
Yeah, I did look at that. So the top probes that come out aren't when we looked at the correlation, you don't really see the very, very small correlation with the brain. I mean, I think what we think we're picking up mainly is probably medication effects with the blood. When we're looking at sort of the blood he was as a schizophrenia. But particularly with the twins, what's interesting there is obviously because they've got the same genetics, you might pick up things that you might miss with the case control studies because they're much more genetically heterogeneous. But we think it's probably more to do with exposures and the majority of that, the thing that's going to be so different is going to be the antipsychotic medication, and other things like lifestyle as well. I mean, the other thing which is interesting is HDAC4. It's not the same probe, but it has been associated with obesity, and we know, especially in the UK, depending obviously what the medication regime is, but schizophrenia patients are often BMI is larger. So unfortunately we didn't have that data on the twins. So but it could be down to other factors as well. Yeah.
So if you were to, just another question, if you were to look at this in normal twins, and you were to correlate the blood and the brain, do you see the effect of the environment more in the blood, or it's
I think it's difficult to set for things like smoking. Like the smoking, obviously, we see a huge smoking profile in blood-derived DNA, looking at demethylation, but we don't see that same profile in brain. So that's obviously exposure you see in the blood, but you do see some, but it's nowhere near as significant in the brain. So that's kind of your question. So maybe some exposures, yes, you might see it in brain tissue, but it's also the brain is very heterogeneous as well. So yeah.
I'm just asking, these twins which were concordant or discordant for schizophrenia, so how many of them are concordant and discordant for other diseases?
Yeah.
For many other diseases, like or exposures to smoking, drinking, lifestyle. So what was the degree of concordance for a range of behaviors?
Yeah, no, that's a good question as well. And we don't have some of the twin cohorts are better have better data than the others. So for most of them, we have some data, and for a lot of them, the co-twin did have a psychiatric or a sort of alcoholism, maybe at least one depression. So they're not completely phenotypic free, which most psychiatrists I speak to would say that they'd expect that. So I guess in that way, maybe we're doing more like looking at more psychiatric at the actual medication. But I guess by looking at this many twins, hopefully we can be more confident that we're looking at schizophrenia rather than something else. But yeah, we don't possibly have enough data. Of course, we could be just doing an EWAS of BMI, I guess. But we don't have BMI, so I can't rule that out. But I guess also the fact that we replicate it in the other data sets as well gives us some confidence that it's schizophrenia we're looking at. But that is one of the challenges of looking at discordant twin pairs, yes.
It was a very good talk, ma'am. I just wanted to have a vague idea about what is the significance of intronic methylation pattern. Because in some papers they say that intronic methylation, if there is a methylation in intronic region, they act as a promoter.
Yeah, well, I think it just will depend on the gene really and where it is, because and that's one of the reasons we're doing these functional studies, so we can really sort of investigate that, because a lot of these studies are sort of big studies and that have just generally profiled the genome, and some of them are sort of are using algorithms to predict, but there's not a huge amount of empirical data, so we just have an open mind. I think they can act as regulatory elements. I think it's going to be cell specific, probably developmental specific as well. So that so it's going to be probably difficult to generalise, I think.
And does it affect with splicing machinery? Whether the intronic methylation, does it affect with the splicing?
Yeah, I think there has been some studies that have found that demethylation can affect isoform, and that's some of the work that John's was talking about. We're using the isoseq, and the idea is to look at different isoforms, and then we'll have the denomethylation data, and we'll hopefully be able to answer some of those questions when we've done some more analysis. Yes. Thank you.
I think that's all for the questions. Thank you very much, Emma.
Thank you.
Oh, sorry. Yeah, we have a small token of appreciation for you. Thank you.